So hello everyone, let us solve today's GfG problem of the day, and the problem name is majority vote. So let us read the problem statement. So you are given an array of integers nums where each number represents a vote to a candidate. Now we need to return the candidates that have votes greater than 1/3 of the total votes, and if there is no majority vote, then we need to return -1. So let us see this first example and try to understand the question and find some solution out of it. So this is the example that they have given, and this question is similar to the question of majority element. So if you don't know this question, you must solve this question first and then come on to this question. And this question solution was based on Moore's voting algorithm. So Moore's voting algorithm. So we will solve this question with the similar approach because this is the most optimized approach with the time complexity of O of n and space complexity of O of 1. And we need to achieve this time and space complexity only in this question as well. So we will use the Moore's voting algorithm in this question. Now in this question, majority element, the frequency that they have provided was n/2. So in that question, the majority element is that element who appears more than n/2 times. Now just imagine if you have n elements, then how many possible number of candidates could be there whose frequency could be more than n/2. So how many elements could be possible? There could be at most one element whose frequency could be more than n/2. That is obvious, and that is also not sure. It can be at most one, it can be 0 as well, but at most we can get one element only. But now in this question, the frequency that they have given or the vote that they have provided to be majority is n/3. So for n/2 we could have at most one element. So for n/3 we can say that there can be at most two elements. Still it is not guaranteed that there will be two elements. It could be 0, it could be 1, or it can be at most 2. In case of 0 we need to return -1. In case of 1 or 2 we just need to return that number. So we will use the Moore's voting algorithm in order to solve this question. So let us see how we will apply the Moore's voting algorithm in this question. So we know that there can be at most two candidates possible to be our answer. So let's say candidate 1 and let's say candidate 2. Now they will have their corresponding vote as well. So let's say candidate 1 has vote 1 and candidate 2 has vote 2. Now this doesn't denote the frequency. I'll tell you what these vote 1 and vote 2 denote. But for now we will start assuming a first element and second element to be our candidate 1 and candidate 2. And we will change according to the frequency or this vote number. Not the frequency, with the vote number. So let's say candidate 1 is 2 and candidate 2 is 1. So we are assuming that this is our first majority element and this is our second majority element, and they have both vote as 1 for now. Now we'll start iterating from 5. Now we come to the 5. Now 5 is not equal to this candidate 2 and it is not equal to this candidate 1 as well. So we can decrease its vote by 1, so it will become 0, and we can again decrease its vote by 1, so it will become 0. Now what does this vote 1 equal to 0 and vote 2 equal to 0 means? So let me show you. So we have covered 3 elements till now. So in this array, let's say this array has size 3. So we want majority elements, so n/3 would be equal to 1 in this case. So we want frequency of element whose frequency is greater than 1. This vote 1 is 0 and this vote 2 is also 0. That means candidate 2 and candidate 1, I mean candidate 1 with value 2 and candidate 2 with value 1 can't be majority element in this case because their vote is 0, and that vote 0 simply means that this 2 got cancelled with 5, this 1 got cancelled with 5, and you can actually see these both are not the majority element. So this vote 2 vote 0 signifies that majority element is not this candidate till now. It can be in the future, but till now these two numbers are not the majority element. So we will assign the new possible majority element to be 5. So let me just erase this. Now we come across 5. We checked candidate 1's vote are 0. That means this candidate till now cannot be the majority element. So we will replace this 2 with our current element 5 and we will increase its vote by 1. Then we will come across this 5 again. So we see that yes, it is matching with the candidate 1. So we will increase its vote by 1. Again, these two are 5. So we will increase the count of vote 1 by 2. So it will be 4. Now we come across this 6. We see this is not matching with the candidate 1 and this is not matching with the candidate 2. But we see that candidate 2's vote is 0. So we can say that this 1 is not the majority element till now in our array. So we can replace this 1 with 6 because that is what we are doing. We will assign the current element as the majority element. So we will increase the vote by 1. Then again we will come across to these 6. So we'll get how many? 4, 6. So we can update its vote by 4. So it will become 5. So we have vote 1 to be 4 and vote 2 to be equal to 5, and this vote is for 5 and this vote is for 6. Now this again does not mean that 5 and 6 are the majority element, because there can be some case we can say that yes, it has the frequency greater than 1 but still can't be the majority element. Because this vote doesn't signify the frequency, it just says that yeah, this can be the possibility that this 5 and this 6 can be the majority element. To find actually this is the majority element or not, we will just again iterate through the entire array and count the frequency of 5 and 6. If their frequency is greater than n by 3, we will assign it to our array. Otherwise, if both of them are not having greater than frequency of n by 3, we can simply return -1. This vote 1 and vote 2 is just possibility of these candidates to be the majority element. These are not the frequency. Just keep this thing in mind. These are just telling that these elements have the possibility to be the majority element. To check actually if these are the majority element or not, we will just again iterate through the entire array and find its corresponding frequency. So let us summarize what we have seen till now. So how many majority elements can be at most possible with frequency of n by 3 greater than frequency of n by 3? There can be at most 2 elements. Now there is a long list of numbers. So how can we say which are those 2 numbers? So we are using the help of candidate 1 and candidate 2 with vote 1 and vote 2. So with the help of vote 1 and vote 2, among the entire array we will get 2 elements which have the possibility of getting the majority element. So we will get that, and in the end we will just iterate through the entire array and check if both the elements have frequency greater than n by 3 or not. If they both have, we will return both of them. If single one has, we will return the single one. If none of them has, we will simply return -1. So this was it about the question. The time complexity is O of n, space is O of 1, and let us write the code now and understand in more better way. So let us write the code now. So we will do exactly same what we have seen in the explanation. So we will assign one candidate 1 and we will assign one candidate 2. So candidate 1 will be nums of 0 and candidate 2 will be nums of 1. Now we will have two variables, vote 1 and vote 2, which will tell the possibility of these candidates to be majority or not. So vote 2 will be initially 0 and vote 1 will be also initially 0. Actually these will be 1, but okay, we will start iterating from 0 index only. So that doesn't make any difference. I++. So let me just declare this n variable. N is nothing but num size and let me also initialize the vector answer which will store the majority element. So if our current element nums of I is equal to candidate 1, then simply increase vote 1 by 1. Else if our nums of I is equal to candidate 2, then simply increase vote 2 by 1. Now if this is not the case, what can be the other possible scenarios? We have already seen if vote 1 is equal to 0 or our vote 2 is equal to 0. So vote 2 is equal to 0. So that means these candidates cannot be the majority element for now. Maybe in future, but for now these can't be the majority element. So we will assign the current element to be the majority element or possibility to be the majority element. So what we will do, we will write candidate 1 to be nums of I. Similarly, if vote 2 becomes 0, we will assign candidate 2 to be nums of I. Now, still we have one scenario left. What is that? If vote is positive or greater than 0 and it is not equal to candidate 1 and it is also not equal to candidate 2, so what we need to do, we just need to simply decrease our vote count of vote 1 and vote 2 by 1. And yeah, this will keep on going, and in the end we will get the candidate 1 and candidate 2 for our answer. Now we need to again check if these candidate 1 and candidate 2 are majority element or not. So what we can do, we can initialize vote 1 to be 0 again and vote 2 to be 0 again. Now we will just simply iterate our array once again and check the frequency of these two candidates. So if nums of I is equal to candidate 1, increase its vote by 1. Else if nums of I is equal to candidate 2, increase the vote 2 by 1. Now in the end, if vote 1 has frequency greater than n by 3, that means this is the majority element, so we can push this into our answer. Answer dot push back candidate 1. If candidate 2 also has the frequency greater than n by 3, that means if vote 2 is greater than n by 3, that means this is also the majority element, so we will push this also into our answer. So push back candidate 2. So let me just remove this. Yes. Now there can be possibility that these two are not the majority elements. We can't get any majority element. So for that we need to return -1. So how can we do that? So we can initialize one flag variable initially to be 0, and if we found any one of the majority element, so we'll just mark this flag to be 1. So flag equal to 1. And in the end, if not flag, that means if flag is 0, that means we didn't find any majority element. In this case we will return -1, otherwise we will simply return our answer. So this was the code. So let us see if this gets submitted or not. So yeah, our code got accepted successfully. So hope you learned from this video. Thank you.